right, welcome to chemistry lesson 6.03 on resonance structures. So let's add a structures to this. So we're continuing on with Lewis structures, and we're going to look at the last kind of variation of these. So we're going to look at, we're on example 5 now. Example 5. What happens if you make a molecule that has 3 oxygen atoms? Right, we don't really have to worry about a stick structure here because we have 3 oxygen atoms. So we're going to put those in a row. Drop my pen. Let's pick a different color. I want blue. All right, here we go. How many electrons are we allowed? Well, each oxygen atom has 6 valence electrons. So that's going to be a total of 18 valence electrons that we can apply. So I start around the outside, 2, 4, 6, 8. There. 10, 12, 14, 16, 18. All right, now I have to check for octet. Oxygen 1 has 2, 4, 6, 8. Oxygen 2 has 2, 4, 6. So this guy fails the octet test. This guy has 2, 4, 6, 8. So what's going to happen is this oxygen is going to want to bring down a pair of electrons. It's going to take its little electron lasso and come up here and bring these guys down into the structure. So we're going to have, let's redraw. I'll share 2 pairs here, and then that'll leave me with pairs here. I've got a pair up top, I've got a pair here. Okay, so total electron check. Number 1, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's good. Now I need to do an octet check. I've got, for this oxygen atom, 2, 4, 6, 8. For this oxygen atom, 2, 4, and both of these pairs count, 6, 8. And for this oxygen atom, I have 2, 4, 6, 8. So my final structure is going to look like, put my pairs on. Usually when we do, I know I have 2 pairs here, we want to put them on opposite sides. But here's the problem. What if it had reached up and lassoed over from this oxygen? It could have happened just as easily. This and this are not the same structure. In fact, in chemistry, orientation and being left-handed or right-handed matters. We can't lay these over top of each other. Well, what happens actually is that half the time this bond is here. So if this is my 1, my 2, and my 3, and this is oxygen 1, 2, and 3, half the time the double bonds between 2 and 3, and half the time it's between 1 and 2. To draw this correctly, we have to draw both. To indicate that both of these structures exist, we do a double-headed arrow between them, and we have to put brackets around. And this is called a resonance structure. A resonance structure. And anytime you have a Lewis structure that's not symmetrical, it's probably going to have a resonance structure. So let's do our last example. Let's do example 6. Let's do a sulfur, 1 sulfur, and 3 oxygen. All right, sulfur has the lower electronegativity, so that's going to be in the center. I'm going to put a sulfur in the middle, and I'm going to put the oxygen around. Now I need to know what my total electrons are, so let's get an electron count. I've got sulfur, I've got oxygen, I've got 1 of these, I've got 3 of these, and they both have 6 electrons. It's going to be 18, it's going to be 6, for a total of 24 electrons. starting with the oxygens, I'm going to start applying them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, octet check. So first thing is, do I have the right number of electrons? Yes. Now I have to check for octet. Oxygen has 2, 4, 6, 8. This is good. Oxygen has 2, 4, 6, 8. This has 2, 4, 6, 8. But sulfur has 2, 4, 6. Sulfur fails the octet check. I have to lasso a pair down to form a double bond. So that gives me, and I'm just going to do it all in black. But who's to say it couldn't have lassoed a pair off of this or off of this? Turns out it could have. So another accurate way to draw this is like this. Let's get our lone pairs on there. But another way to draw it would be to put the double bond here. That's also accurate. So all three of these actually exist, and that double bond takes turns spending time at each of these different locations. To indicate these are all accurate, I put the double-headed arrow and I do my brackets to indicate this is one Lewis structure. So that's my resonance structure for what we're going to come to learn is called the sulfite ion. Okay, or I'm sorry, sulfur trioxide. We're going to call that sulfur trioxide in the next chapter. Okay, and that does it for resonance structures. We're finally all the way through all of our examples, and you'll have one more assignment, and this last one has resonance in it. So have fun with that, and we'll see you in the next lesson.